So here's our visual again. We have g of x equals the absolute value of x, right? So there's our absolute value function. What we're going to do this time is we're going to add in a constant h. If you notice, I'm going to move my little bar here to the right. I'll move it to, let's say, 1. So our h value is a 1. You can see that that 1 showed up inside the absolute value bars. Now in the vertical translation, that number was showing up outside of the absolute value bars. So if you add in a constant inside the absolute value bars, you can see how our graph translated. It didn't go up or down, but it this time went to the right. If you guys remember the tricky x, this says x minus 1, which makes us think it should go toward the negative numbers, but it's tricky, so it's actually going to go to the right. So as I continue to move the cursor, you can see now in the function we have x minus 3. So we were at 0, 0. That's going to translate us 1, 2, 3 units to the right. So any number that you add into your absolute value bars, inside there with the x is going to translate and shift the x's. What happens if we go on this side? So if we get some negative values. So here are our constant that has been added in is a negative 2, but because of tricky x, it looks like a positive 2. So if I see a plus 2 in the absolute value bars with the x, I know that the parent function is going to shift 1, 2 units to the left. You'll notice that is changing where the vertex is. And the axis of symmetry is the line, the symmetry line that goes through the vertex. That is going to move as well. If we're shifting left and right, your axis of symmetry shifts along with your graph.
Okay, so we just saw that visual. Let's just look at this example right here. We can see the parent function f of x equals the absolute value of x right there. And then g of x equals the absolute value of x minus 4. So we put in this value. This is our h value. Our h value, we've got x minus 4. Tricky x means we're going to go to the right 4. So our parent function has the vertex at 0, 0. It moved to the right 1, 2, 3, 4. This is now where the v is. So that would also change the axis of symmetry. Axis of symmetry is going to go right through that vertex, which is now at 4, 0. So let's take a look at a couple quick examples. For each function, identify the vertex and the axis of symmetry. So when we look at a new function, we want to see how it looks different from the parent function. We've got our absolute value bars, so we know it's a V-shaped graph, but we got the x minus 3. So anything inside the bars with the x is going to be a horizontal translation. So this is going to translate, because it's a, let's make a note, tricky x, it says minus 3, we're going to translate to the right 3 units. That's going to move your vertex to the right. So our vertex now is at 3, 0. And then that axis of symmetry also shifted along with the vertex. So now our axis of symmetry is at x equals 3. All right, p of x, we have the absolute value of x plus 5. So again, what do we notice? We've got our absolute value bars, so it's a V-shaped graph. We are adding a constant into our absolute value bars, so that is going to be a horizontal translation. But then we've got our tricky x, so it says x plus 5. We're going to translate to the left 5. When we translate to the left 5 units, that's going to move the vertex to the left 5 units. So now our vertex is at negative 5, 0. And the axis of symmetry is going to shift along with it. So the axis of symmetry is that vertical line x equals negative 5.